Hi, Pre-Calc Honors. So today we're going to graph tangents and cotangent functions with transformations. So in the past we did graph these last year, I believe, without any transformations, and we also have done some Desmos activities where we graph tangents and cotangents. Go ahead and, but again, today with transformations. So go ahead and read the objectives and read the paragraph. We're going to skip around a little bit. So some of these problems, I'll have the answer key available for you to do. So still, again, all important problems, still do them. But we're going to focus on this video on the tangent and cotangent graphs. So go ahead and pause the video and read the paragraph, and then I will meet you on problem number problem number three. Problem number three. Go ahead and pause the video and go ahead and read. Okay, welcome back. So we're going to graph a tangent and a cotangent. So let's take a moment to go back to GeoGebra, and let's start with a tangent curve. So let's think about, first of all, tangent is, let me get my pen here. Great. Okay, so a tangent curve, a tangent of theta is sine of theta over cosine of theta divided by cosine of theta. So we're thinking about asymptotes. So wherever the cosine of theta is 0, for a tangent curve, you're going to have an asymptote that is undefined. Let me go ahead and make this look a little better. There we go. Okay, so let's go ahead and get started, and let's think about what would happen at 0 degrees or 0 radians. So we have sine over cos is 0. So again, here's a point right there at 0. But let's think about what would happen at, and again, these are touchy, so I'll just get close. Oh, look at that, at 90 degrees. So at 90 degrees, or pi over 2 radians, notice your sine over cos would be undefined. So again, that's where we have our asymptote. So you might want to take a moment now to even think about with your calculator. I went to mode and I am in degree mode. So if I say, what is the tangent, for example, of 89 degrees? What is the tangent of 89.5 degrees? What is the tangent of 89.9 degrees? What is the tangent of 90 degrees? So note, sorry about that. Delete, let's go back. What is the tangent of, clear, start again, tangent of 89.9 degrees. So notice we're getting, we have a y value that's approaching infinity, tangent of 89.999 degrees. Look at that. But then the tangent of 90 degrees, as we know, is undefined. Okay, so here we go. So let's go ahead and think about what would happen then. There we go. We have another cycle. So let's think about like the tangent of 91 degrees, for example. Enter, clear. So the tangent of 91 degrees. Oh, sorry. There we go. Tangent of 91 degrees. What would happen? The tangent of 90.5. We're getting, as x approaches 90 degrees from the right, what's happening to the y value? The tangent of 90.0001, for example. Wow, that's a really small number. So now notice we definitely have, as our x value approaches 90 degrees, or in radians, pi over 2 radians from the right, our y value approaches negative infinity. So there's our cotangent, or a tangent graph. So why don't we go ahead and take a break now from GeoGebra, and let's consider problem number 3. So if you were to graph problem number 3, this is how I like to do it. I like to start by thinking about the tangent curve, or the tangent function, I should say. There it is. Without any transformations at all, the period is pi, because if you remember, the asymptotes were at negative pi over 2 and positive pi over 2. But notice here, the period will be 2 pi, because we have a horizontal stretch by a factor of 2. We're going to reflect over the x-axis. We're going to stretch it. and we're going to move up 4. Let's talk about the stretch first. So notice if this is typically has a period of pi, this graph of tangent, at pi over 4, or if we're in degrees, 45 degrees, notice that you would have a y value of 1, and at negative pi over 4, if you're in radians, or negative 45 degrees, if you're talking about degrees, you would have a y value of negative 1. But now with this vertical stretch, that will be stretched, so that would be a 2 and a negative 2. Okay, so let's go ahead and just think about our y equals tangent 1/2 x. So now the period is 2 pi, and if we look at one cycle, notice we would have an asymptote at negative pi and positive pi. We didn't move right or left at all, but we did move up. So let's go ahead and look over here. Here's our graph. So we're going to have an asymptote at negative pi, and then another asymptote at positive pi, and then pi plus 2 pi is 3 pi. So we'll have another asymptote at 3 pi. And notice we have a reflection. So this graph will be reflected. Okay, so it's going to look something like that if we have a reflection in there. And notice we moved the whole graph up 4. And so that's our point of inflection. And then, again, so we could graph. And I probably should have thought about what would happen halfway between, because again, we talked about how usually it would be one above, one below if you're halfway between. But notice at negative pi over 2, instead of going up 1, we would go up 2. That looks about right. And at positive pi over 2, we go down 2. That looks about right. So 2 above and 2 below, that y value of 4, which we might want to call the midline. And the period was 2 pi, so there you go. You might want to draw another cycle in there. Go ahead and pause the video and see if you would be able to describe the domain and range. In fact, I'll do the range for you, all real numbers. Go ahead and try the domain. Okay, so do we realize that you're going to have a value at every, the domain, well, the only restrictions will be where the asymptotes are. So all reals except x equals, let's grab any asymptote, how about pi, and add the distance to the next asymptote times k, where k is an integer. So why don't you go ahead now and try to graph number 4, and the video part 2 will guide you through that one. So go ahead and try it on your own, and then go ahead and click on the link for the next video.